Welcome to D-Lab, everybody. Project of the day is Silverface Fender Vibro Champ. Came to the shop dead. The owner suspects the power transformer went out, and I agree. We'll check that out in a minute, but first I got a mystery box in about a month ago and I'm just getting around to opening it up. So I'd like to share this with you guys. I haven't actually taken anything out of the box, okay? So it came with a note. It says, "Hi Terry, D-Lab. I hope you have time to repair a few of my amps. I know you've been swamped, but hopefully you can use the items in the mystery box, right? Your pals and avid YouTube fans, viewers Josh and Max Mars." Really appreciate it, guys. I'm sorry it's taken me so long to get to it. I've been like swamped, people. I've been turning down repairs left and right, and I think some are getting upset at me, but I don't have the room here in the shop, and I don't want to delay people for months, right? So it's better that you hang on to it rather than me, okay? Anyway, let's take a look in the box. I'll turn the camera, we'll get right down in it, and you can see it as I pull it out. Here we go, mystery box. Opening up. Get it back here out of the way so we got room to put the goodies down here. Little bubble wrap. First off, some very nice heavy-duty leather guitar amp handles. I'm always using those, guys, because you know I build a lot of those little combo amps. Nothing than that. So a 1/4-inch patch cord. Might be good for a speaker, not sure. Got a collection of those little Velcro restraints for cords. Wrap them up. Very nice. I don't have any of those, as a matter of fact, guys. I believe that is a telephone line cord. I haven't built any amps out of telephones. The day could come. This appears to be some type of a coax. Feels like Teflon. It looks like 12 gauge red. And appears as though that might be some more of that coax. I'm going to have to investigate that. Because you know I do a lot of work on ham radio stuff. Here's some of it that's actually stripped. It is coax. These might be good for like reverb tanks, right? Little shop rag. I'll put that in my car. Because I'm always using all Mars just paper towels. She gets mad at me. Got some miscellaneous line cords with a switcherino. Flashlight. This guy really did make a mystery box. One of those AC extension little guys there. Another handle. Man, it keeps on going and going. Like some pretty heavy duty heat shrink tube. Jumper clips. I use those all the time. You guys see me do that because I'm too lazy to make up cables. More parts of that handle. That feels like hardware. Ace hardware. 1024 screws by 1/2 inch. Excellent. Pencils. I'm always using that for my layout work. Matter of fact, I use those little lead pencils and I run out of lead and I'm out of luck. So this is cool. I do have a sharpener. What we got here? Dragon's Blood. You got me on that one. Incense. Okay, that's why you got me on that one. Some little Electro Harmonix book. Some of their Wizmo gizmos. Very cool. Another patch cable. Electrical tape. That's a good deal right there, guys. I go through a bunch of that, especially when I'm pulling wire through heat shrink tubing. I use quite a bit of electrical tape. Scissors, that's a good thing because I always leave my scissors in weird locations. There's another pair. And then I go and take Marcia's and she gets mad at me again. She gets mad at me a lot. Another little jumper clip. A hole saw. Man, this guy put a lot in this little box. What's this? Is this cord restraints? Nope, they're little rubber feet. Very cool. Some more heat shrink tube. Another of those nifty little flashlights. Some wire. This This looks like what you'd see on some of those little extension speakers from a sound design stereo. Very cool, man. A lot of this stuff I will use. These incense, I'm going to have some fun with this. I might actually let Emmy experience what an incense is. I need to open those up. We used to have these when I was a kid. My mom would burn them all over in the house. She had little wood stands that would hold them at an angle. And I used to get into those and get in trouble. Very cool, guys. I'm going to have a lot of fun with this. I'm going to have to get Emmy and Marsha out here and let them check it out. Fun, too. I appreciate it, Josh and Max Mars, for you guys thinking about me, spending the time to pack this, and of course paying the shipping to get it to me. Very cool, guys. Thank you very much. Now back to the Vibro Champ. Alright, I told you guys this came in dead, right? So what I'm going to do in this video is, obviously I'll fix it, but I'm going to concentrate on some of the details. In this case, we'll talk a little bit more about the power transformer. We'll buzz that out and compare it to the new transformer and see if you can detect the failure with a meter or if you have to actually power it up to see the defect. So let's go. So let me demonstrate the problem that we have with the Vibro Champ. Remember, it came into the shop dead, blowing fuses. So I already suspect something shorted in the power supply. At this point, the Vibro Champ has no tubes in it. Power switch is on. We're hooked up to my little Tenma Variac over here. So if I swing over to the Variac, I'm going to bring up the voltage slowly. We're monitoring current. You see that current? It should be laying at 0. There should be absolutely no current flow except for the dial lamp. And it sure isn't going to pull that kind of current. So yes, we do have a short on the chassis. Now I've showed this before, but we're going to go ahead and go over it again. Let me get a little closer. We'll hook up a meter. We'll find the short. I've got the chassis tilted down on my nifty Mojo Tone amplifier test stand so I can show you guys what the issue is. So I started probing around immediately on the different windings of the power transformer looking for a direct short. The only place I see a direct short is right here on the filament line. You should not have 0.3 ohms to ground. Imagine 6.3 volts across, in this case 0.25 ohms. So I suspect we have a short on the filament winding of the power transformer, so I'm going to desolder it here real quick. I've raised the wire now for the filament supply. So now first we'll go right back to the back of the lamp where I was measuring before. Now you see we jumped up to about 6.5 ohms. Go to that winding, whammo. So I'm sure if we hook back to the Variac, our short is gone. Let's go ahead and check that. Back on the Variac, haven't changed anything on the amp except for that wire now that we lifted, and look, I still have my short. And the wire is up in the air. What's that tell you? Internal short on the power transformer. Gonna have to change it. So as you know, in the past I've always used classic tone transformers, but I cannot find one for the Vibro Champ. So I elected to go with a Hammond 290AX. This is also a drop-in replacement. Same windings that you see on this transformer, except this original one appears to have had a couple different primary windings, whereas this one we just had the straight 120 volt windings right here. If I can get them in my hand, the black line. So this is your primary, yellow is your 5 volt, green with the center tap is filaments, and of course the red's high voltage. So I need to change the transformer, put in a fresh filter cap, remove the death cap. We're going to bring this thing up on a Variac and verify that the power supplies come back to life. So now that I've got the power transformer removed and totally isolated, I'm going to address the subject that many of you have wrote in about. You ask, hey, what are the typical resistances of these power transformers? Okay, so now we have it out, let's do a comparison. Remember, this transformer had two sets of windings, so I tied the primaries back together the same way that they were in the amp. So we'll go to low ohms. Got my trusty Beckman 360. So that primary is 5.6 ohms. Primary on the new transformer. About 4 ohms. Right? Here are the 5-volt windings on the old transformer. She's pretty low. Let's go down to the 20 ohm scale. So you can see that's like ultra low resistance. Here it is on the new transformer. About the same, almost not even measurable. Okay. Let's go ahead and check the 6-volt winding, because we know we had a problem with that, right? Also, very low resistance. Now let's check our new transformer. Remember, there's a center tap, so you want to get the two solid grains to measure this. She also appears very low. So resistance wise, they're looking pretty much identical. Alright, let's check our high voltage windings. You see I ranged up because these are normally over 200 ohms. About 330 across the two reds, and then if you go to the center tap you should see about half of that, which I don't. Go over here and check it again. So there's a big imbalance on the high voltage windings. Let's compare it to the new Hammond. About 269. Now the Hammond has two sets of high voltage windings, but we're just going to do a comparison on one. So here is that center tap, about 130 and 130 something. So look at that. This one is much more balanced. So maybe the issue I was seeing with this transformer is some type of crosstalk, we'll call it, between the high voltage and the filament circuit. So for the fun of it, now we have it totally out of circuit, I'm going to hook the variac back up to this primary and let's see if the transformer all by itself pulls high current. So here's that power transformer hooked up direct to my variac with nothing applied to the secondaries. See that current? We still got not a short but a high current path in that transformer somewhere. So yes, it is defective. Time to change them out. Alright, so lesson learned about troubleshooting these power transformers. Even though this one was obviously defective, I really could not detect that defect with my ohm meter. The only way I could actually see the problem is when I applied power to it. So the windings buzz out okay, but internally there must be something going on, like some windings shorted to each other, so the inductance is wrong. So the only way that you're going to be able to spot this is to isolate the transformer, bring it up on a variac. Okay, a lot of people change transformers thinking they're bad and find out, oh, there was a short on the chassis, or oh, the depth cap was shorted. Okay, so isolate it, test it, then you'll know for sure if you have a bad component. Got the new Hammond power transformer and new CE distribution filter capacitor installed. We're almost ready to power the unit up, but first I wanted to point out something. You see this filament line here, the twisted pair going all the way over to the first 6V6. You're probably wondering, why did I do that? This is for the initial test, okay? This lead goes to ground, and this lead is the high side feed that hits all the tubes. That is how this amp was originally wired. If you get one of these Hammond power transformers, you're going to notice they have a center tap. If you connect that center tap In this configuration, you will not have 6.3 volts going to your tubes. You're going to have about half of that, okay? I planned later on to go ahead and wire this up like you see the newer style Fenders with the floated twisting pairs going across each tube. So the filaments will actually ride above ground and the center tap will be there to knock down the noise. But for this test, I wanted to just hook it up stock so we can make sure the power supplies are operating. So here we go. So here's the initial power up. I only have the 5Y3 tube installed. My Beckman is monitoring the high voltage, and I've got a 25K high power resistor to dissipate that voltage when I'm done testing. Bring it up on the Variac. You should see the dial lamp over there illuminate when we get some action going. Look at there, there's our high voltage. So that tells me that the high voltage winding, 5 volt winding is good, and I do see the filament lamp over there illuminating. Currently I'm at about 90 volts input. You see we got about 320 volts plate. That's all I need to see. So I'm going to bring it back down. We'll do a little bit of eyelet capping, okay? Get the tubes installed and put a signal through it. Here we go. Initial power up. I put in a new bias resistor on the 6V6 because the 470 was always too light, so it's up to a 750. There is the cathode voltage drop across the 750 ohm resistor. It sounds like we got amplification. Good deal. Alright, I'm going to put a signal into it. Alright, just hooked up my audio generator. You can already hear the audio kind of bleeding through a little bit. There's the output. Tremolo's on. Plenty of volume. Treble work? Let me see. Yep. Bass. So she is functioning. Good sign. Now what I want to do is get in here and go ahead and wire the filament circuit with the twisted pairs and get that center tap hooked up. I updated the filament wiring, so now the center tap is connected to ground. We've got our twisted pair filament feeds at right angles, and then back here you'll see some 22 gauge wire that's actually coming around here and feeding the front GE47 lamp. I do this because I like the high current off the filament transformer to land on the tubes where it needs a current, and let that little guy up front that's drawing 50 milliamps have 22 gauge wiring. Well, sure enough, bad power transformer. It's a bummer, but I've been seeing a higher frequency of power transformer failures in these vintage amps. I'm sure it has a lot to do with the fact that they're like 50 to 60 years old. They're going to start failing, and luckily Hammond had that drop-in replacement because I can't get my classic tones anymore. Alright, so I hope that you guys can appreciate this approach to the repairs rather than just, hey, I got a broken amp, I'm going to fix it, let's play it type routine. I want to shake it up a little bit, maybe concentrate on some of these failure modes and give you some tips of how to identify these bad components so you don't waste your time and money. If you guys like this approach, let me know and I'll keep doing it. We'll break out of that old routine, something new, maybe get you guys more engaged. Tell me what you think.